In this video, we're going to practice the function transformation rules for quadratics, vertical translation, horizontal translation. So vertical translation will be plus d on the outside of the function. So you want to recognize when we are moving from the quadratic parent function and you're adding a number on the outside, just as we are here, it's the true sign, and we're going to be moving up or down. So if there's a plus 3, we're going to be moving up. If there's a minus 3, we're going to move down. When you see a quadratic function and you have subtraction inside the parentheses with x, we are going to call this a horizontal translation. Horizontal translation means you're moving left or right. And think about parentheses. Parentheses are on the left and right side. So a horizontal translation right 3 would have a minus 3 on the inside. So you think about it as the opposite sign. Okay, the opposite sign, we can write that here. If you see a minus 3, you would think you would move it left, but because it's the opposite, you're going to move right 3 units. If you see a plus 3 on the inside, again, you're moving the opposite of that plus 3, so it's left 3. So opposite. So if you see it on the inside of the parentheses, you're moving left or right. On the outside of the parentheses, you're moving up and down. Very similar to your linear function transformations. Okay, let's go ahead and look at an example. We're going to practice and describe the transformations on f of x that results in g of x. So you want to recognize this is function notation, and if they give you f of x equals x squared, we want to recognize this is our quadratic parent function. And we're going to talk about the transformation to g of x. G of x is the new function. It's a transformation. And we're going to graph f and g on the same grid and complete the tables and describe the transformation. So first of all, if I see f of x equals x squared, that's a parent function, and then I see the transformation of plus 1 on the outside of the parentheses, I should recognize on the outside of the parentheses it's moving up or down. Because it's a plus 1, we would be moving up. So in order to fill out our table, f of x is going to be filled out as a parent function. And for the parent function, negative 2, 4, negative 1, 1, 0, 0. Oh, this should be it. Not that one. And 2, 4. So what you want to notice is that your axis of symmetry keeps the same distance from each of those points. So your y-intercept for your parent function, this is f of x, is at 0. So keep that in mind. Make sure you recognize your transformations are always going to be from your parent function. Now, in order to find the table values for g, what we're going to do is add 1 to the y values. Because this is moving my graph up or down, it's to the y values. So my x value stays the same. If I add 1, this becomes negative 2, 5. My x will stay the same. All of my x's stay the same. And I'm just adding 1 to the y values. And notice that the y values do repeat after you see that axis of symmetry. So if I'm moving up 1, my vertex is going to move up here 1, and then I'm going to have negative 1, 2, and 2, 5, negative 2, 5. So I kind of drew it overlapping, but you can see that at G has moved up 2 from the origin. So we completed the table, we graphed them on the same grid. We're going to just describe the transformation. Well, we know that the transformation is going to be a vertical translation up 1 because there's a plus 1 on the outside. Let's look at another example. Here we have f of x equals x, and g of x equals f of x minus 2. So here I want to recognize my parent function. This is where it all begins. So my parent function has the same exact table from earlier because negative 2 squared is positive 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So graph that. That's f. Now, in order to identify g of x, again, nothing happens to your x values. They all stay the same, but this transformation will change the y values. So if I see a minus 2, that means I'm going to be moving down 2, and I'm going to be subtracting 2 from all the y values. So 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2, negative 2. And then these just repeat here. So now we're going to go ahead and graph g. And if we're going to move down 2, you start at the origin, at the vertex, move down 2, and that's your new point. Negative 1, negative 1, 1, negative 1, negative 2, positive 2, and again, you want to recognize that, I'm sorry, this should be a 2. All my x's should have stayed the same, and I messed up right there. So here, again, you want to recognize that your axis of symmetry holds as that middle piece, that part where it cuts in half, and when you go up and to the left, up and to the right, those 2 points are the same distance from the axis of symmetry. All right, so the vertical translation down 2 units is because we have a minus 2 here on the outside. Again, this is a transformation. This is a new function. Below, we're going to try and graph f of x equals x squared. So that's your parent function. So it's at the origin. Again, it's the same distance from your axis of symmetry. And if I'm going to graph the transformation of minus 4, I want to recognize it's on the outside, so it's going down 4. So I'm going to go from the vertex, go down 1, 2, 3, 4. And then everything from there is the same distance. And I can show you how to graph in the calculator if you can join for class these 2 types of functions. So writing a verbal description, the graph of g is translated down 4 units from the graph of f. If you need more time, go ahead and pause the video. I'm going to move on to some more examples. Now we're going to look at horizontal translations, translations where you're moving left and right. So here we're going to describe the transformation from f of x, which is equals x squared, which is a parent function, and f of x minus 4. This is a new, g of x equals f of x minus 4. This is a new function. So this is a new one, the transformed, and this is a parent function. So in order to identify our table is still the same. Our x values here stay exactly the same. Our y values stay the same for the parent function. But now that we're applying a minus 4 on the inside of the parentheses, that's to the x values. So to find the table of values for g, we're going to add 4 to the x values. Remember, it's the opposite sign of what's in here, so we're adding 4. So when you add 4, I'm sorry, your x value should not stay the same. So this should be a positive 2 because negative 2 plus 4 is positive 2. It's my y values that are staying exactly the same here. So you can repeat the y values. Your x values are changing. Negative 1 plus 4 is positive 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. So now you graph both of them. The parent function starts at the origin. And they're the same distance from my axis of symmetry, those points. And this time, what I need to recognize is if I added 4 to my x values, my graph is going to shift over. So 2, 4, 3, 1, 0, 4, 4, 0, 5, 1, and 6, 4. So here you're going to notice that my vertex changed to 4, 0. It shifted over to the right 4. So to describe the horizontal transformation, it's right 4 units. A horizontal translation, right 4 units. In the next example, we have f of x equals x squared and g of x equals f of x plus 3. So again, your parent function stays the same, but this time because we have a plus 3 on the inside, you want to remember that you're subtracting 3 from the x values. So your y values stay exactly the same in this entire table. It's your x values that are changing. So negative 2 plus 3 is negative 5. Subtracting 3. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 3. Negative 2. 2 minus 3 is negative 1. So now if you graph both of these functions, and you're going to see it becomes 1, 2, 3, 4. Easier as you graph the parent function. You get used to seeing those points. And if we're moving, you're going to notice here, now your graph is shifting. You're shifting to the left for the origin. And here, negative 4, 1, negative 2, 1, negative 1, 4, and negative 5, 4. Again, they are the same distance, these points, from your axis of symmetry. So if I drew my axis of symmetry here, you're going to notice each of the points are the same distance from your axis of symmetry. And so last, to describe the transformation, it's a horizontal translation, left 3 units. It's on the inside, opposite, you're moving left 3. So let's go ahead and look at a few examples where we're going to describe the transformation, and then we'll move on to the last few examples. So here, if you notice, it's on the outside. Describe the transformation from f of x, the parent function, to the result of g of x. G of x is a transformation. If it's on the outside of the parentheses, that's to your y values, and you're moving up if it's a positive, or down if you see a minus. So here it's plus 6, so it's a vertical translation up 6. That is exactly what you're looking for to describe. Here, we have g of x equals x minus 3 squared. On the inside is the minus 3. So inside the parentheses, it's left if you see a plus sign, or right if you see a minus sign. It's the opposite. So here, it's a horizontal translation. And if you're moving minus 3, it's going to be the opposite. So right 3, opposite sign, to help you recognize the transformation. And here, the last example, there are 2 transformations going on. So in the last example, I see a minus 2 on the inside. So remember, on the inside of the parentheses, you're moving left if you see a plus sign, right if you see a minus sign, and on the outside you're moving up or down. Up is plus, minus is down. So because it's a +2, you're moving horizontal translation left 2 units, and on the outside is -1, so it's a vertical translation down 1 unit because there's a minus sign. All right, we're going to move to the last few examples that I have, and then you're going to go ahead and get started on your Desmos activity. On this next example, you're given your transformation, and we're going to graph them based on the description here. So here your parent function is already graphed for you. If I look at this transformation, I want to recognize that the -6 on the inside is the opposite, so I'm moving left 6. The +4 is on the outside, so I'm moving up 4. So I'm going to move left 6, 1, 2, 3, 4, 5, 6, and then I'm going to move up 4, 1, 2, 3, 4. So this is my vertex now. From my axis of symmetry, I'm going to go up and over and this is going to be the transformation. So from here, you can describe the transformation as a horizontal translation left 6 units and a vertical translation up 4 units. The next question is asking, did the vertex change as a result of the transformation? Yes, it did change. The vertex shifted over left and up 4, so it's -6, 4. And the last question is identifying the equation, and the equation is exactly what they gave us. If you're moving left, it's a +6 on the inside. If you're going up, it's a +4 on the outside. In the next example, you have g of x equals f of x minus 9. So the -9 on the outside, you want to recognize that you're moving down 9. So this is your quadratic parent function. I'm going to go down 9 from the vertex. 1, 2, and then up 1 over from here. This describes the transformation. So vertical translation down 9. The y-intercept, did the y-intercept change? Yes, the y-intercept has changed from 0, 0 to 0, -9. It shifted down. And my equation is g of x equals x squared minus 9. Now, I'm going to go ahead and show you a few graphs, and we're just going to describe the transformations. Here, on the graphs below, graph A, you want to recognize it has shifted up. So from your parent function, which is at the origin, you want to visualize this is your parent function, and I did a terrible job of drawing, but it shifted up. So this is just one transformation, a vertical translation up 3, and you have a +3 on the outside. Here you want to recognize from the origin that your graph shifted to the right 2 units. If it's shifting to the right 2 units, it's a horizontal translation, and you should have a -2 on the inside of the parentheses. And last, the transformation here is 2. You're going down, and you're going to go left. If you're going down, you should have a minus sign on the outside. If you're going left, you should have a plus on the inside. So it's a horizontal translation left 1 and vertical translation down 2. And so your function is going to be g of x equals x plus 1 squared minus 2. Go ahead and practice in your Desmos and explore the activity.